Okay, we're at the top of the hour. How are we
Yep.
doing this? Oh, I lost somebody.
We've
I
got
offended somebody.
we've got a good audience here. Welcome everybody to the an in-depth look at Idem that got announced on the keynote stage yesterday morning. Tom Hatch, the founder and inventor of the Salt project, and still at the helm as we've joined the VMware team. So I'll turn it over to you, Tom. And I just want to ask one more thing. Do you want questions to come in discussion style, or do you want to save those to the end and have them queued up in the Q&A tab?
Let's do them discussion style this time.
Okay. All right. So,
really
folks, if you have questions, putting them in the Q&A is going to be a good way to make sure we don't miss them. If you actually want to talk verbally, go ahead and submit a request to present or to show your microphone and camera, and I'll grant that, and we can have this be an open discussion with Tom. Does that work, Tom?
Yeah. And as I was saying, Jeff, I appreciate you asking that at the beginning. Different presentations are conducive to interruption in different ways.
Yeah.
So, like the last presentation of mine, that Jeff moderated, was on open source in the enterprise. And then the whole presentation, I had kind of a predefined flow that I was going for. Whereas this one can be broken up a little bit more because it's more of a lot of informational points that we can iterate on. All right.
Awesome.
Let's dive in. Welcome to day 2 of SaltConf. Here we are. We're doing this thing again. So many SaltConfs. We're here to talk about the Idem project. Now, one of the things that's really interesting about the Idem project is that this has been a subject of research on my part for quite a few years. And cloud automation, obviously automation, is something that I've spent a pretty significant portion of my career on, and heck, my adult life. And one of the, if anybody listens to my podcast, The Hacks, or if anybody's frankly listened to a number of the other sessions that I've had, one of the main problems that I see in the world at this point from just a software in general perspective is that we build software to solve technical problems first, when we need to be considering all of the human problems that are interacting with the software. We do need to be very aware of building elegant and powerful asynchronous decoupled models, all those wonderful things. But we need to account for the people problems as well. And my goals around Idem are to figure out how to solve those people problems. Now, I'm going to take a brief tangent. We went out and we got a new logo for the Idem project. I think it looks fantastic. I'm a big fan. So we're going to be seeing that a lot more. This is the first time we've really publicly posted it. We're looking to have website and things up soon. And so if we've got time at the end, I'll also give a status update just on where we are, what we're trying to do, what we're trying to get done. This is obviously a very massive undertaking. And there are a lot of liabilities, a lot of issues we've got to deal with on a lot of fronts. But so the core problem with the cloud is scaling people. One of the things that I found quite fascinating is that I go back to the beginning of my career when I was building data centers and doing system admin work. So my first job out of college was, I dropped out of college and I got a job. My first job out of college was teaching classes for Red Hat. And so I was a trainer, and it was interesting. I learned a lot about how Linux worked in that job. And more importantly, though, as my career progressed, it was really interesting because it was just at the beginning of virtualization taking a very ubiquitous hook into infrastructure. Because my career really started in earnest in tech in 2007. And virtualization had been around for a long time, but it was at that point where we were seeing the beginning of the modern cloud movement. And I think it's fascinating as I look back, how many more projects we manage in the cloud and how we look at application deployment in the cloud so differently than how we looked at application deployment and management 15 years ago. I mean, we go back 15 years ago, we would still have arguments with people about whether or not they should be using Windows in the data center to present apps. I mean, that is a rarity now, whereas that used to be much more dominant. And the thing that's been really interesting to me from kind of a macro philosophical perspective is that in the early days of cloud, it was all about just saying, it was basically saying, hey, we got virtual machines in the cloud. You can log into a UI and you can spin up some VMs, but we still manage them in a classical way. But now we've broken apart the applications to the point where the nature of the cloud infrastructure has become very, very complicated. And I feel that while that has given us massive benefits from an application deployment and management perspective, it has also made a shift in how we work with people and how people scale in application and infrastructure and cloud management. And I also think that this is an artifact of the dominance of open source over the last decade. Open source was definitely well established in, say, 2010, but not like it is today. And the incredibly strong, yes, the logo is a small I. The incredibly strong open source influence, I feel, is one of the reasons why we need a high level of expertise when it comes to deploying software. And that higher level of expertise is expensive and it doesn't scale well. What I think we need over the next 10 years, and I would argue this is one of those pendulums that swings back and forth, what I think that we need over the next 10 years is to figure out how to make it so that cloud scale is something which is considerably less complicated. We need to simplify the chain of events that exists between somebody making an app and making it run and scale. And that it's very hard. That is the goal of Idem. But to accomplish that, we can't simply solve the problem of saying, hey, here's a high-level cloud interface. What we need to do to solve that problem is that we have to take what is an incredibly diverse and divergent set of APIs and capabilities, and we have to make it so that it's possible to have high-level automation custom built in a repetitive way on top of it. And so to do that, to simplify the complex orchestration of the cloud, we have to look fundamentally at a number of the problems that we're dealing with. And we have to ask, where are the real bottlenecks? And the real bottlenecks, again, they're coming back into people. And so what are the people problems in cloud automation? And so again, I've spent a lot of time here, and I feel like I've boiled it down to people who are developing the apps and people who are deploying the apps. So when I say users in this slide, I'm looking at it from more of a cloud automation, an SRE kind of role. We need to speed up the automation capabilities. This is an incredibly broad statement, To speed up automation capabilities, we can't simply look at things and say, oh, infrastructure is code. We can't look at the old solutions. We need to be able to auto-ingest what's happening in the cloud and automatically create reproducible automation based on the easiest mechanisms that a person can construct what the structure of the cloud should look like. And so to do this, we've got to have a certain type of insight into how a cloud works, but we also need to manage and enforce the state of a cloud in a different way. But then we have developer side issues. Over the last 15 years, the graveyard of cloud automation is significant. And one of the major reasons for that is because the maintenance overhead from a development perspective is so large to just keep up with this massive proliferation of cloud APIs. Just step back and look at the list of vendors, and then look at how many services inside of Azure and AWS and all of these others need to be continually racked and maintained. Amazon Web Services is a massive multi-billion-dollar business. One of the most successful tech endeavors on the earth today. They have so many people creating new applications that keeping up with their APIs is incredibly daunting. And then we have to consider that that is merely one vendor, which is taking one approach to cloud automation. And even with the vast array of capabilities that are inside of Amazon AWS, we still have to use other services. We still have to integrate with GitHub and GitLab. We still have to automate multiple different CI/CD pipeline tools. And we still have to automate the fact that we're deploying applications in a hybrid cloud environment. And I'll quantify the word or term hybrid cloud by saying the term itself is so incredibly nebulous that keeping up with how it works is just, it's ridiculous. And so we have to be able to tackle the problem of that scope. When I first wrote Salt Cloud, the scope I was tackling was spinning up virtual machines. Completely different overall view. And so it was easy to come back and say, oh, I've got 10 clouds and I'll write how to spin up virtual machines. Yay, it's 2011. But so we have to have answers to both of these questions. These answers have to permeate into the architecture of a platform. And that platform itself has to be built in such a way that its own development can scale and solve high-level solution issues. This is an incredibly daunting task. And one that, if I'm completely honest and transparent, there are plenty of days where I wake up and say, why did I bite this off? I just could have, come into VMware and rah Salt forever. But apparently I have a rabid and irresponsible level of ambition. But that's what life's all about. Otherwise, I don't think it's worth living, honestly. So how do we solve these people issues? Now, I'm going to start and dive into some of the nuts and bolts here, but mostly because that's where we are. First, I want to talk about something inside of Idem called Idem Describe. And for those of you who went to Tyler's session yesterday on Idem, he did a fantastic job and demonstrated that Idem Describe, if I'm not mistaken. Idem Describe can scan a current cloud deployment and generate human-readable code. This means that the entire low-code concept has just shifted. Somebody with Idem can easily go into whatever interface and define exactly what the cloud looks like They point item at it with item described, and they get all of the SLS data that they need. They get all of that information back into an SLS file. And those SLS files, since SLS is very human readable, since SLS is made to be auto-generated, I mean, that was one of my original assumptions when I made SLS data back in 2011. And also, I feel it's a very proven infrastructure as code model. And so all of that can be generated. And that also is part of how the salt state compiler and therefore the item compiler works, because it is first and foremost a data compiler over an interpreter. And so by using a structural data compiler that has interpretation pass-through as the language interface for SLSs, which I'm now referring to SLSs. For those of you who've been in Salt for a while, the term SLS used to mean, the term SLS originally was intended to mean salt state, which is terrible. We're now referring to it as a structured layered state, which I think is a much better descriptor. And also because we're beginning to repurpose that overall linguistic structure. So we can generate that code, and it reapplies at an incredible level of reliability. And it does this because of a few deeper concepts inside of item. One is pure idempotent repeated reconciliation, so that since it's idempotent, we can just keep hitting the APIs over and over again in a reconciliation loop, and in many, many respects simply allow the cloud to do our ordered reconciliation. But item also has a concept called transparent requisites, which means that it can transparently embed requisite information into the runtimes, which means that in the vast majority of cases, you don't need to worry about requisite relationships anymore. We magically take care of those for you. But of course, they're always still at your disposal. The requisite system inside of Salt, and therefore inherited inside and extended upon inside of item, is very, very powerful. Next, we've got the concept of layering. I was saying before that we need to be able to orchestrate high-level complex deployments. To be able to orchestrate high-level complex deployments, we have to be able to have higher-level abstractions around what those types of deployments look like. One of my goals with Idem is that Idem can be the foundation for tools that would be similar in user-friendliness, let's say, to maybe a complete FAS Django style system. The challenges that we run into there is that we would need to be able to write code and have that automatically deployed in a transparent way across multiple services inside of a cloud. If we have the layered components that we do have inside of Idem, in almost entirely thanks to following a POP style architecture, then what we are able to expose is, again, that layered infrastructure, so that we can have all of the fundamental capabilities inside of Idem, but then constantly build higher level pieces of functionality that give us higher layers of abstraction with simplistic defaults. The next problem that we have to solve from a developer perspective is the pluggability of Idem. One of my favorite things to talk about, to the point where I wonder if people are just ill of hearing it, is plugins. If I were to be diagnosed with an obsessive compulsive disorder, my primary symptom would likely be an obsession with plugins. At this point in my career, I just can't think about code in a non-pluggable way. Idem is built on top of POP. POP allows us to create extensions to a software platform that are entirely separated from the core platform's code. And that separation from the core platform code means that someone can extend item without me ever knowing about it. I mean, I'd appreciate a shout out, right? But I don't have to review the code of every contributor in every project. They can be developed independently. This gives us such a more significant level of flexibility in how we utilize and develop this software. But one of the other things that's important is that this is not limited to specific components. We're going to talk a little bit about exec modules and state modules inside of Idem, but the plugins inside of Idem can be extended to every layer and facet of the application, down to the definition of the execution runtime. That is completely pluggable. The entire Idem execution runtime plugin for parallel execution is less than 35 lines of code, and it can be completely replaced because of aggressive pop-style compartmentalization. This also means that ingesting parts of the code should always be a very simple thing to do.
Tom,
So again,
I apologize for the interruption. You have a question in the Q&A tab. It's gonna pull us back to the discussion of describe.
oh, can we have describe for salt? I would love to have describe for salt. That's definitely something we should look into. And there's a lot that we could learn there. And then Jazz Eckert says, regarding plugins, I noticed that there are multiple repos in GitLab for Idem components. If I want to use several of them, are there multiple executables to call from the CLI? Yes, if you want to use several of them, you pip install them, and then they just work. And that's it. You pip install them, and they extend and then that activates the POP subsystems and what we call vertical app merging inside of POP, and they just work. That's all you got to do. And then that also means that the distribution component is, just take a look at the documentation around that. And you install those extra components, and you can directly call them by calling Idem exec or calling Idem state. And then those components are now available instead of your SLS files or directly using Idem execution calls. Okay. You bet. So next, there's a concept inside of SALT which has occasionally been argued against SALT, but I've stood by for what I think is very good reasons, is the separation of execution modules and state modules. This concept is alive and well also in Idem, but it's very, very powerful as to how it's being used and how it's being deployed. And then we're going to talk a little bit about that later. And then finally, Idem is idempotent. I have had many arguments with people over the years that SALT is idempotent. Duh. And occasionally someone comes and they try to accuse me of SALT not being idempotent. And I was so terribly annoyed by this, especially when I was writing Idem, that I decided to just name it Idem, as in idempotent. It is literally named idempotent. It is very fundamentally meant to expose idempotent interfaces. And so that's what it is. And that's how it is all the way down. And since it is completely idempotent, it allows us to create idempotent and declarative systems which are incredibly powerful. So let's talk a little bit in depth about a few of these one at a time. Idem describe scans. Idem describe is able to scan a cloud infrastructure and extensively gather all of the information about said infrastructure. And take that information and then map it directly back to SLS data. Now, the reason that we can do this is actually because, not only because SLS data is structured, but also we can do this because of the way that our APIs are fundamentally written. And this goes into a problem that I'm going to address in a little further. The APIs that we have are small because how they work is that they create direct bridges to the cloud APIs and auto-generate and auto-map to these new API bridges. This significantly lowers the development overhead because we go into an API and then map it back to a data structure interpretation, which we then map back to the Idem SLS structure, which is a little more powerful than the Salt SLS structure because I've got a little more flexibility in how it's built. And that gets us 99% of the way, not only to describing an infrastructure, because the very API interfaces that we use are direct mappings to their upstream representation. But that also means that it gets us 99% of the way in the describe functionality of just generating those SLS pieces. So that again, it becomes incredibly simple to simply look at a cloud and say, well, what would this look like if I reproduce this? And we just get it. With that said, there's always a reasonable chance that you'll need to tweak this code a little bit. But we will, but we will be able to get somebody 99% of the way there. And again, that's something I'm incredibly excited about because we have to be able to ingest existing infrastructure. A lot of, from a product development and a theoretical perspective, there's this concept of in-band and out-of-band management. That's the idea that somebody who's managing an infrastructure maintains a data set of the infrastructure in a CMDB style approach, and that they're only able to see what they have done. And yes, Idem does respect API versioning. To answer Jas's question, I'm not going to go into how right now. So that in-band and out-of-band concept is that's actually one of the reasons I wrote Salt, was because I was fed up with dealing with CMDB and cloud databases that didn't have up-to-date information. One of my core motivations inside of Salt was to be able to look at an infrastructure and simply ask and say, tell me what's actually going on. I just need to query the infrastructure as fast as I can query a database. And that was one of my core motivations to make Salt so darn fast. And so that concept is alive alongside of Idem, that I don't want us to have to be dependent upon a database that we try and pretend is the source of truth. The source of truth needs to be reality, not a data store. And so Idem Describe seeks to make the source of truth reality. Next, Idem is like an ogre. Actually, I have to say that's probably the most overused joke in the world, to go back and continuously reference Shrek every time an onion shows up. These layers are really important inside of Idem. That's right, Nick. Idem is like a parfait. Everybody loves parfait. Okay. If we come back and look at the layering inside of Idem, it is directly inherited from Pod, which is built from the ground up for this stuff. And the whole idea is that Actually, this is SaltConf. I'm going to talk about this in kind of a Salt concept. Inside of Salt, one of the problems that I ran into in the plugin loader is that if you want plugins to be able to cross-call each other, they've got to go through the plugin infrastructure. And that plugin infrastructure is generated when we scan the plugins. And that meant that cross-calling between plugins was an early but difficult thing that I had to build into Salt. And inside of Salt's loader, we have static linking between loader instances. And that static linking between loader instances is all about manipulating the Python module layer. And I really hate that that's how I did it. But if I go back in time, I couldn't possibly imagine another way to pull it off. Inside of POP, I solved that problem because you don't ever want to modify the module layer inside of Python if you don't have to, because that means that your sysmodules and import of the modules gets dirty. But more importantly, that gives you static cross-linking inside of your plugin system. When I got rid of static cross-linking inside of POP, that meant that what we're able to do is have completely dynamic cross-calling and layering without any functional overhead. And that was really one of the big moments for me inside of POP development. And that means that since every plugin subsystem inside of Idem has complete dynamic cross-calling, the layering becomes natural inside of the paradigm. So now that I've wasted 4 minutes of your time trying to explain like plugin-oriented theory, what that means is it's super easy to write high-level abstractions. And that's critical. Creating these layers is something that you can do outside of Idem. You just pip install the code and it works. And that's really exciting. So I've been referencing POP a lot. I am, for those of you who know where my mental obsession is, it's really inside of POP. I'm crazy excited about Idem, but at the same time, I need to be honest, Tyler Johnson's done the majority of the Idem development over the last year. I've been there to direct and architect and assist, but I haven't had hands-on code, which makes me sad. But big shout out to Tyler. He's really helped us carry the Idem project through the last year and helped socialize it and keep it strong inside of VMware so we get to the point where we are now, where VMware is increasingly committed to the Idem vision. And so, yeah, huge thanks to Tyler Johnson. And at the same time, a lot of my obsession, honestly, is around POP, right? This is what I think about at night. And being able to have a pluggable infrastructure component is what enables Describe. It's what enables us being able to abstract all code interfaces down to generatable data interfaces and simplified data interfaces that are simplified to the level of a JSON serializable data components. Because I want to be able to look at POP always from a complete, continual, data-driven development perspective. And so again, using POP as the engine gives us ridiculous amounts of plugin power. But now when we talk about automatic code generation. So we've been enabled automatic code generation through a bunch of technical hooey. And so let's talk a little bit about how this works. When we started doing code generation, I wanted to make sure that we had multiple venues or mechanisms for code generation. Mostly because I was well aware of the fact that if I didn't have multiple mechanisms for code generation, they wouldn't be able to work across multiple APIs. And so we have two major code generation mechanisms. And API pass-through can actually be argued that they're argue that there are two mechanisms for API pass-through generation. One is API pass-through through SDKs. We have built into POP and Idem now the ability to traverse SDK code and convert it into data structure representations on top of POP's plugin hierarchy. This allows us to transparently push error and API access directly to the SDKs. This is very exciting. Next, we have API scanning techniques, which build API data translation models. What this does is scans REST APIs and converts the REST API data structures into reproducible direct REST API call structures and back into the POP data hierarchy. Being able to have that level of data translation, again, gives us this direct API pass-through. It's beautiful. And so that direct API pass-through means, and so both of those mean that we can basically push a button and have full access with sometimes less than 20 lines of code. Full API access translated into Idem's infrastructure for the entirety of the Azure cloud. That's a big deal, and something we're incredibly excited about. Next, we have documentation scanning. And so in some cases, you just can't build a continuous data model across an API. And so for this, we've got reusable documentation scanners. And so these documentation scanners are able to go out and look at the documentation of APIs and dynamically create not only execution modules, which is that direct pass-through layer, but increasingly, they can also auto-generate the states so that we can auto-generate over 95% of the code that's used to create idempotency on top of the actual direct APIs. Needless to say, this makes it a little more manageable to keep up with clouds. But if we don't do that, I think we just know it's impossible to keep up with these flipping clouds. All right. We have the exec and state systems. That, again, is very important. It's critical that we were able to separate direct execution and idempotency layers. And David Fiddler is asking, did we talk about interfacing? I said that yes, we can interface with multiple versions of APIs, but that I'm not going to go into detail on it here.
While you're looking at the chat, you have another question in the Q&A tab as well.
What? Can you, so, yeah, I did answer David Atkins, I believe. Can you talk about config drift and your thoughts on that subject? Yes, cloud config drift is something that needs to be maintained, and we've actually got, we're actually in the process of making some additions right now to make that a little more powerful. My initial thinking around, and still holding on to this, is that drift with Idem can still be maintained through multiple idempotent calls and a polling interface. I think that makes a lot of sense. One, because Idem's runtime is completely asynchronous and parallel and scales very, very well because it doesn't have to spawn any additional processes. And it entirely uses the Python async IO internal loop. Now, this is critical also because if we look at other programming languages, you have to implement plugin interfaces instead of separate processes. In Go, for instance, plugins have to be different processes. And so that creates a significant amount of unnecessary CPU and memory overhead. We don't have this limitation inside of Idem. And so that means that we can make large-scale parallel calls across lots of APIs at the same And so again, that makes it a lot easier to do continuous enforcement and maintenance. With that said, also, one of the things we do plan on adding into Idem in the future is cloud event tracking. I'm not doing that right away because I think that we've already bitten off a lot to chew. But that event tracking should also allow us to have continual event-driven configuration consistency as well. There's also a question about implicit and explicit configuration consistency enforcement. And Idem is built to be able to allow both so that you can have enforcement. The goal is that you can have implicit enforcement, which means that you have enforcement of every aspect of the configuration as it existed upon instantiation, or you can have explicit enforcement, which says these are the only values I care about. So I'm only going to enforce these values. I don't care if somebody tweaks or manages a different value. And then you have continuous discovery. So Idem also is incorporating the described functionality into standard iterations and runs, so that in a very soon upcoming version of Idem, we're not quite done with this one, but we'll be able to have complete rollback visibility across multiple iterations of the Idem process. That should give us the ability to take arguable snapshots in time of complete cloud configuration and reapply them. Because every time we do an application of a state, we're using describe as the discovery backend for that comparative analysis inside of the idempotent process, and then we're storing that those active descriptors. Who was that? Was that Benassi? My man Brett Benassi? Yeah, does that answer your question? Okay, okay, that's a smiley face. Yes. Exec versus state. Again, this is a SALT concept that we continue using. And that separation between raw API access and idempotency allows us to have significantly more development access into the backplane of a cloud. This is very, very useful when it comes to actually developing higher level abstractions. And I would say critical for higher level abstractions. Next, I want to talk a little bit about the declarative nature of Idem. Idempotency is extremely difficult for a number of reasons. Not only is idempotency difficult because merely being able to have a complete status of a component before enacting change is difficult, but you also have relationships that are difficult, and you also have abstracting idempotency to an end user, which is very difficult. End users in the human mind have a hard time generally thinking about creating code which is a broad, singular, enforced state. Humans really like to think in a more iterative fashion. Do this, then do that, then do this, then do that. It's difficult for us to comprehend a complete state. I mean, just try it out. Like, look at the room around you and try and imagine that room in a complete, contiguous, perfect state. It's hard to do. But if you look around the room and say, what would this room look like? How would I clean up this room? It's a lot easier to say, oh yeah, I really need to take care of that stuff in that corner. And it's even more difficult for the human mind to simply say, this is the declarative state, and this is how it's magically going to get there. I have to repeat Hans's comment where he says his room is in a complete, contiguous, perfect state of messiness. So, abstracting that to the human mind means that the infrastructure as code componentry needs to be delivered in a imperative way, and evaluated in an imperative way, but enforced in an idempotent way. And that in and of itself is a daunting task. And so we do that inside of Idem by following models that we built originally inside of Salt, and of course, extending them again for the use case. Which again, this is one of the reasons why I'm really excited about Idem, is because it inherits so much wisdom that we've gained over the years inside of Salt, and hopefully packages them up in a way that can be even easier to work with. And so Salt, as many of you are probably aware, is evaluated iteratively, and then imposes or executes declarative and idempotent constructs at runtime, so that it executes in a completely deterministic fashion, following an iterative assumption with declarative overrides. Idem is the same way as Salt in that regard. So we still have all of the capabilities inside of Salt's requisite system, and then some. And I have to say and then some because cloud automation mandates different paradigms from a relationship perspective. And so one of the things I'm really excited about inside of Idem, and that I put a lot of energy into, is that inside of Salt, the requisite resolution process is a multi-forking recursive algorithm, which works great, and it's fast and it's efficient. Whereas in Idem, it is a pre-evaluated sequence without recursion that allows us to abstract requisite constructs in a pluggable way. So requisites in Idem are pluggable. Requisites in Salt are near darn impossible to write, and adding them is really hard. Requisites in Idem can be added with 5 lines of code. And it's really, really fascinating. At least in my opinion, after spending so much time doing requisite resolution and so much code, to get to the point where we can have relationship definitions based on simplified rule sets that are contiguously enforceable inside of a parallel system, and have that abstraction sent to such an incredibly simplified level. I'm really excited about how requisites work inside of Idem. All right. The last thing that I want to mention is that fundamentally what we are trying to do is deliver a universal cloud automation engine. This means an automation engine that can be utilized by higher level software, that can abstract human interfaces. For any of you who were in my presentation yesterday about open source in the enterprise, a lot of what I talked about was the fact that open source software development is really good at building platforms, and enterprise and software development is really good at building end user interfaces. And having a universal cloud engine means that we should be able to apply this concept of a platform that we're developing on that is accessible from high-level tools. This is something which is, in most cases, I'm going to argue, something that we do a generally terrible job of from an open source perspective. Open source perspective, we're good at making APIs and intercommunication, but access into those APIs from a high-level user perspective is often quite difficult. And so this is one of the primary goals of Idem. And keep in mind, Idem is Apache licensed, right? I actually had a long discussion about this with the head of the open source office here at VMware to make sure that the licensing of Idem and Idem components were optimal for a broader strategic approach. And the conclusion was to stick with Apache, which I have to admit made me happy, but also surprised me a little bit. I thought that there would be other considerations, but we honestly want a completely open community. And that open community is something that is mandatory for delivering a universal cloud automation engine. And so Todd Carpenter asked I have to reference this picture really quick. This is the Rolls-Royce Merlin engine, which was the engine incorporated into the majority of Allied aircraft near the end of World War II, and gave us a massive advantage in the P-51 Mustang over the skies of Europe. All right, I'm done. I'm done with my war references. Todd Carpenter just asked a question: is Idem a feature that will only be available in the enterprise version of SALT? If so, what will be the limitation? What will the free versions or free limitations be? Idem is open source. Okay. When I talk about it as a cloud engine, Idem itself is made to be completely useful and functional from an open source perspective. The enterprise components that you see that will use Idem are going to be VMware products, which are very targeted towards a non-infrastructure as code user, and to solve those human problems. And so these are things like direct integration into Idem by products like VRM. That's where the separation is. We're not making an enterprise version of Idem. That's a bad way to write software. And if I'm very transparent here, this is an argument that I had back inside of SaltStack with SaltStack management over and over and over and over and over again. And really, it boiled down to naming. My main argument was I never wanted to name SaltStack Enterprise. It's a terrible name. I wanted it to be a separate product, which solved separate issues. But from a management perspective, I lost that argument repeatedly, and tried to explain that if we try and build a GUI on top of Salt, then we're solving problems for people who don't want that problem solved. Where we gained most of our traction with SaltStack Enterprise wasn't with the direct Salt abstractions in a GUI, but they were when we began to solve specific problems for teams that are peripheral to a core Salt user.
Like SecOps.
Yeah, like SecOps, like NetOps capabilities, these sorts of things. That is what it is all about. That is not, and when I say all about, that's not me just saying that's how you make money with open source. That's how you write software. Is understanding that the open source development process isn't really good at delivering a GUI to end users.
Tom, in the last couple of minutes before we hit the 55 mark where we need to wrap it up, you do have another question in the Q&A tab.
I do. Rate limits. One of the challenges that we are running into with Idem is definitely the existence of rate limits. Because of the parallel execution across the APIs, we can hit those APIs a lot and much faster than other tools. With that said, the fundamental way that Idem works is through a reconciliation loop process, which we're still formalizing in a few ways. The goal here is that reconciliation loop can be timed out relative to your API rate limiting, which should be able to give us the multiple stages. The other thing is that again, multiple stages and extracting multiple components makes it a lot easier for us to deal with those rate limits. And so that can be hard. But we do have things in place for handling rate limit errors, as well as being able to scale against rate limits. Okay, does anyone have any other questions, comments, arguments, or rebuttals? Let's see. Sorry for repeating yesterday's Question: long term, what things Idem will do better for end users than Terraform, Pulumi, CDKF, etc.? Where will it be worse than existing tools? I can't answer that in 5 minutes.
or in 30 seconds, because we're supposed to end now so that
Yeah,
people have
I've
a
actually got a
chance.
setup for my next one.
Yep.
Max, we plan on having extensive documentation about comparisons across these multiple tools, the problems we're trying to solve, that they are trying to, that we're not, that they're trying to solve, that we're not trying to solve, yada, 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 yada. That's extensive documentation. But yes, we are planning on being much more, very, very open about answering that question. All right. Off to the next one, everyone.
Thank you, everybody. Thank you, Tom. Appreciate the review and the deep dive into Idem. Hope everyone enjoys the rest of SaltConf, and please hang around for the demo jam. There's a lot of really cool stuff going to happen in there. Thank you all. See you in the next session.
Demo Jam's fantastic.